Rob joins us today from the University of Leeds in the United Kingdom. He has a BSc, an MSc, and PhD in extractive metallurgy and worked on gold, platinum, and uranium in South Africa before joining the University of Leeds. His research interests shifted to the application of gold mineralogy and exploration geology, and he has worked in many areas of the Canadian Cordillera for nearly 20 years. Britt specializes in exploration geochemistry, alteration modeling, and multivariate data analysis. Currently, Britt works with Gold Spot Discoveries, a group of geoscience and data science experts who work collaboratively to bring data-oriented solutions to the field of economic and geology and mineral exploration. Rob and Britt, over to you. I'll be back in 10 minutes to facilitate our short Q&A session.
Right, good morning, everybody. Thank you, Krista. Thank you to Geoscience BC. There we are. For inviting us to present our research. Welcome to the rather soggy north of England. This is our starting slide. You can see here some of the team and the main players, which comprise a very large number of tiny gold particles. So I'm going to start off by just taking you through the background to the project, give a broad framework, and then I'll flesh it out a little bit later. We're developing an indicator methodology based on gold. You might be familiar with the indicator methodologies for lots of other, lots of different minerals, but maybe not for gold. This is relevant because, as you know, the geology of BC is extremely complicated, both on a sort of large scale and a small scale. So placer gold is very widespread, much more widespread than you'd imagine from looking where the placer mines are. But because the geology is so complicated, it isn't always clear where particular gold particles come from, and what the source is. If we could unpick that and clarify where the source of the gold was, then it would be a useful thing to do. How will we achieve this? Well, you need a kind of prospector, any age, any size, or any size of company, from an individual to a large multinational. You collect some gold grains, and then they are subject to compositional analysis. That gives us a signature, and we can compare that signature with those of specific deposit templates. That's one of the main workflows of the project, to develop those templates for that comparison. The interpretation of this is the second main type. So the methodology to interpret those data sets will be dealt with by Britt in the second part of this presentation. The overall effect is that we aim to improve targeting. I'm sure you're very familiar with indicator mineral methodology. Just encapsulate it in this slide here, where I start by irreverently eroding some of BC and generating a load of detritus. And some of the minerals within that we can use because they have an intrinsic link to their source, which we are hoping might be an economically worthwhile mineral deposit. To be a useful indicator mineral, they have to fulfill a couple of criteria. Need to be specific, and they need to be durable, need to hang around long enough for us to find them. So where does gold fit into this? Well, it does the durability thing pretty well. The trouble is that when we find bits of gold in a pan like this, if we're in one of those areas of complicated geology, it may not be clear what the source of the gold is in terms of a deposit type. So what can we use to give us a heads up on where this gold might have come from? We can use some compositional characteristics. Majority of people are familiar with the concept of gold being an alloy of with silver. If we do cross sections of gold particles and analyze them by electron microprobe, EMP, we may in some cases get detectable copper, mercury, or palladium, and that helps. Because we're sectioning, we also reveal mineral inclusions within polished sections. So these help to build up a mineralogical context of the original deposit type. Key thing, does every gold particle exhibit the characteristics? No. So we have to collect populations, and then we study compositional ranges rather than go on individual values. As I said, most people are familiar with the concept that gold contains silver. And here is a plot distilled from 40,000 individual analyses that gives the mean silver values of populations from different deposit types. And the reason I've put this up here is because it's quite clear that these are focused in this sort of 6 to 20% silver range. So if you find a gold particle and find out it's got 8% silver, and it really doesn't tell you much at all, because it's not at all diagnostic for the source deposit type. So what can we do? We can use the EMP analysis to get that raft of elements on the left-hand side, should they all be detectable. We can do the suite of mineral inclusions, quick plug for a paper in press there. And we can also turn to laser ablation because that has an advantage of lower detection limits. So the hypothesis is that we can extend our range of detectable elements and provide more discriminants. Turns out it's not quite as simple as that, and that's a whole separate talk in itself, but we generally get some more useful information from LAI's ICP-MS. So far, the project has analysed a very large number of gold particles. There's the geographical spread there, give you an impression of the range, and those are linked to the mineralization style. You can see in the key on the left-hand side by the pie chart. The particles themselves are from the collections of University of Leeds and UBC, and there's over 12,000 that we've looked at so far. So do the signatures correspond to deposit type? Well, if we think about them, yes, but is the answer to that. The orogenic gold, like any other type, gives us a range of signatures that go from very clear, because we've got other chemical elements other than gold there, or inclusion signature, we can distinguish them, to unclear. And that's the same for all of the deposit types that we've looked at, although what constitutes a clear signature will vary in each case according to the particular characteristics. If I just rearrange these into a radial pattern, then we've got a sort of blob in the middle there that's just gold and silver, no other information, and it's pretty difficult to unpick. We then sort of span out to an area where you can probably interpret it if you spend your life looking at these things, but otherwise it might be a bit tricky. At the extreme, then it's quite easy. We can move from the inner to the outer simply by looking at more data and firming things up. But one of the main aims of this project is to let other workers interpret these sort of difficult to decipher signatures. And I'm going to hand over now to the outrageously talented Britt Blumel to explain how this is going to happen.